Awesome, thank you. So big welcome from my side as well. Thanks also for the invitation to Matthias and the Sneak team. So I'm Tobias. I'm a solutions engineer at Auth2, so not from Sneak. We're focusing more on the front end and how users can log into apps, how to secure that part. And I also want to start with that, with our first talk, which is about securing the front door. So as you've all probably have seen, the whole theme around this specific meetup is about how can you build a secure full stack application? How can you secure that? What I want to do is, just starting presenter mode here, is give you an idea of what does it take to build a modern and secured front-end system, and also on a more technical level, what are the protocols involved if you wanted to do this, and what are just the things and moving pieces you have to be aware of when you think about building your own identity and making sure that users can access your app. And I don't have any slides with me about Auth2, as this is vendor agnostic protocols and standards, but just to give you some idea where I'm coming from. So Auth2 is a developer-focused identity platform. So that means we focus about how can we build the right SDKs for developers to get started easily? How can we manage all of the things I show you today, which are standard-based, so you don't have to be an expert on it, but also how can we extend on top of that? So if you're interested in that, feel free to reach out to me, but that's all I have for marketing. The rest is about tech in the next 30 or so minutes. And also, if you have questions, it would be great to have them in the end, because we have quite a lot planned in this talk, and I'm not sure if I can fit it in 30 minutes anyways, but then we will have some time for Q&A in the end as well. Generally speaking, what I would like to show you, or where I'm coming from, is if you think about how a user can access your application. This seems pretty simple in the first place. You have a login, you have an email and a password, and that's all what's to it. And this login box is a necessity in nearly all apps. So I would say 90–95% of applications developed nowadays have some sort of login. It's not even about applications anymore. It's also about your smart fridge. It's about white papers you want to download. You need all of that for your customers. And it's also very important for you to have a login box, because this is the first impression you're going to make to your customers. If I want to use a service, but I can't figure out how to sign up, I just won't. And this is something we also see a lot in our data that we have, that it's crucial to have this first impression nailed down, especially if you're in a B2C sector. So what is it that, or what's involved in building this? At first, it's just a login box. Then you might want to bring in additional authenticators like Microsoft and Google, and my animations are going crazy here right now. But it's about how can I not only sign in users so I have to manage the passwords, but also how can I make it easier for them to access my app. Then the next step, it's about how can I bring in multi-factor authentication? How can I enable users to sign in via an SMS they get, via their Face ID, Touch ID, any biometric data we have about that user. And ultimately, it's also about how can I communicate that information about a user who's now authenticated and authorized back to my application. And for those of you who are maybe newer to identity, this separation between authentication, authorization basically is, in authentication, we check who is that user. So through things like biometric detection, to passwords, to SMS, we check who is the person who's coming in here. And then the second part is authorization. What is that person, or it doesn't even have to be a person, what is that entity, that thing that's accessing my application allowed to do within my app? And all of this is handled by protocols, lots and lots of standards to navigate, and lots of things that will come along your way if you get started in building such a front end. So this is not even about how to store user data, how to store passwords. We're looking at it from a very generic way, if you just want to have any login capability on the front end, how would you secure that? And we're talking about standards for authentication, authorization, information transport. And if we just look like, I highlighted some in bold that I want to cover today, but just to give you an idea where we are coming from, there are specific protocols, for example, for how should an identity provider be federated into your own application, or what that means in more feasible terms. How can my users sign in with Google, with Microsoft, with any identity provider you have there? All those providers like a Facebook, Google, GitHub follow a certain protocol called OpenID Connect, or sometimes SAML, which makes sure that whatever identity provider you want to bring into your own app, you can easily do so. And you can just switch identity providers out, add new ones without having to go through the proprietary APIs of each and every vendor by yourself again and again and again, which also brings great security benefits. It's about how can I communicate the information that I gather within my app to my, or within my login box to my application. This is OAuth2, and OAuth2 and OpenID Connect are kind of related, but more on that later on. And it's about JWT tokens. Maybe you heard about that as well. So even if you have no interest in working with identity, once you start using an identity system, you will always come across these weird JWT tokens, which is basically information about who is your user and what are they allowed represented to your app, or at least that's the format they are coming in. And then there are also very exciting things going on in the identity. Apart from this standard, cool, you can now log in with Google, Facebook, which is about how could you, for example, use your Apple Touch ID on any website out there? How could you use your Face ID, Windows Hello, on every website out there? And how could you sign in theoretically to Amazon using your face, or to any other website, which opens completely new capabilities of making sure users are actually secured, and that you have a strong trust. This is really the user who I want to sign in, who's accessing my app today, right now. And this is what this talk will be about today. So the highlighted protocols, except SAML, for time reasons, to be very frank, will be covered in today. So I hope you have a good understanding of what's actually going on when a user starts using your application. And just to start with OAuth2 in there. OAuth2 is a standard that basically thinks about how can a user access, or how can an application on behalf of a user access some resource. So think about it more abstract. How can I log into my tax system, and that tax system can receive financial data about myself? How can I log into a financial app, and a financial app gets data from my bank or my broker? This is what OAuth2 handles, and this is authorization. So basically, what is a user allowed? It doesn't really spend a lot of time of who is that user anyways who wants to access things, but only what are they allowed to do. And in OAuth2, we basically have 4 parties, and this is important. So I'll go through them because we will need this for the other protocols as well. We first always have a resource owner, basically a person which has access to some data, which owns some data. So this could be your financial data, this could be your shopping list in Amazon, this could be your repositories in GitHub. You're the resource owner of all of those things. And this information is lying on a resource server. So on some place in the internet that stores all this data. Now, OAuth is all about how can we enable a client to access this. So if you use Gitkraken, how can Gitkraken access GitHub, the resource server, on your behalf? And in order to ensure that this is possible, we need an authorization server. This authorization server basically knows who is a resource owner. So without even specifying how to authenticate that person. That's just a capability we assume every authorization server has, that they're able to say, okay, this is the person, and they hold the information, what resource does that person want to protect, and also what permissions would that resource have to be accessed with. So we don't only have access to, now you have access to the full repository, but do you want to have read permission, write permission, update permission? The authorization server knows about all of that. It also knows about clients who potentially want to access this data, and it can issue tokens, more on that later, which then prove against the resource server that a client is allowed to make an access on behalf of the resource owner. That's pretty complex on its own. But once you get through it, it's actually a pretty straightforward flow you will look at. So if we go to another example that I brought here, we walk through it one by one. The idea behind OAuth is I, as Tobias, open Outlook on my device. Within our company, or let's take it even more absolute and private, in Outlook, I now want to fetch all my Gmail data. So we have my basically Google protected resource server. On the Gmail servers are all my emails that I want to access now through Outlook. So what happens is that Google has the information about what information it has, namely all the emails. Google knows about or has defined some permissions to access this information, read data, update data, read calendar, update calendar, and Google knows me. I have an account with them and they forced me to sign up before I could start using this email. So what our client, Outlook, now can do is Outlook can register itself with Google and say, hey, I'm an application which wants to access email data on behalf of users. And then when I actually go to Outlook, Outlook can make me sign in with Google and verify with Google that I'm willing to share this data with Outlook. And then Outlook, on behalf of myself, can get all this data and import it into Outlook from Gmail. And that's the basic idea behind this. So to keep in mind, OAuth2 specifies how can the client access this resource server. It doesn't say anything about how does Google authenticate me? How does Google do this verification? When OAuth2 kicks in is, I now authorize Outlook to access all of this information. And to make it a bit more technical, but also that you understand what would go on. If we look at the specific flow of or changes that we're having, what would happen is I would access Outlook. Outlook would then redirect me to Google to authenticate me. So now I, as the user on my browser, are on Google, I authenticate. OAuth2 doesn't assume any way of doing this. So this is just happening magically, so to say. Google has free choice of what it does there. Then after Google authenticated me and after Google got my consent that I want to share this data with Outlook, they will send a so-called authentication code back to Outlook, usually. And this authentication code doesn't contain any information yet. So it really just says, dear Outlook, I can confirm now to you that the user is authenticated and willing to give you this data. What happens then is Outlook has to take this code and trade it with Google again to obtain an access token. So the idea behind this step is Outlook then gets the explicit permission and this token, which says Outlook is allowed to access Google data on behalf of this user. This is what this access token specifies. The reason why it has to trade this in is because in this step, Outlook can again authenticate itself to Google as well. So Outlook has a client ID and a client secret, and it can tell I, as Outlook, I'm really Outlook. Here's my secret, which verifies that I'm a really Outlook and not someone else who's trying to break into this account. You gave me this code, and now I trade it for this access token, which then allows me to make calls against Google, and which then allows me to access emails, resources, all of that kind of stuff. And that's the basic idea. So that's already a lot, but I've built a very small demo, which probably or hopefully will make this a lot more sure or certain, clear what I'm talking about. But this is basically the idea about OAuth. Two, let's say, computers talking to each other on behalf of a person to get access to a resource. There are some alternatives to this. And I'm only mentioning this because if you want to start doing OAuth, you will very quickly find some best practices, some self-claimed best practices, which are actually anti-patterns in disguise around how to use this and how to make this more or less secure using this whole thing. So there are some alternative flows from this redirect. For example, you couldn't do all of these redirects on a single page application because the flow I just showed you always assumes that we have a backend server. So this second trade of getting an access token from an auth code should happen on a server, because only then you can be sure that this client secret is actually secure. If you put that into the client, everyone accessing your website can read out the client secret. It's not secure anymore. But if you just don't have a backend server, you could go for single page applications. If you have no user at all, you could still use OAuth. So if you would just say two machines talking to each other, for example, in a microservice scenario, you could use that as well. And if you have some legacy apps, and this is just some advice I'd want to give you here when you start looking into it, you will find a lot of implementations which say, just use this. And this resource owner password grant, in essence, just means send the authorization server an email and a password, and then the user is verified. Done. This is actually super insecure, and there's a lot of material out there explaining why. But just keep in mind, basically, there are alternatives, but all of them have in mind of authorizing a user to access a protected service through these users, through clients, so for example, Outlook, and through scopes, which is then how am I allowed to access this file or this data. But before we jump into the demo, we haven't clarified yet who that user actually is. So we have OAuth2, which was the, let's say, earlier protocol, which only specified authorization, but we still have no clue how do we actually authenticate the user. And this is where OpenID Connect comes in. So if you hear OpenID Connect, that always includes OAuth2, because OpenID Connect builds on top of the OAuth2 standard. So those are basically, it's not a extension per se, OpenID Connect, so it wasn't the same people who wrote it, but it assumes that you have an OAuth2 server, and it just specifies if you have an OAuth2 server, how can you actually authenticate users. And what OpenID Connect really does is it specifies for identity providers what are these standard endpoints. So we talked about Outlook redirecting myself to Google. What URL should I be redirected in order to do something? It specifies how should my information be encrypted in a standard way, and where can I find this encryption information on the authorization server. And it also specifies additional means to get info about the user, because right now we only got an access token back. So Outlook only knew what am I allowed to do now on behalf of that user. What OpenID Connect does is it started bringing an ID token as well. So you will get back information about who is that user actually, what's their email address, their name, their profile. This is all things that OpenID Connect specifies on top of OAuth2, and that enables a lot more things. Because with authorization alone, we would have to integrate every Facebook, GitHub, and Google of this world on our own with our own proprietary endpoints, and we wouldn't really know how to approach all of this. With OpenID Connect, we now can do authentication-only logins. So it isn't always about, let's get an access token and then asking the server in the back who my user actually is. But we can get info about the user just throughout the login step, which makes our application more scalable, because we don't have to look up who that user is in each and every single step. It enables easier identity federation through standard endpoints. So we can just swap out any identity provider who complies with OpenID Connect for one another. And in the end, that enables that you, as a developer, are very, very flexible and just switching identity providers and switching with what service basically you want to integrate now. And I want to show you just real quick how that works. So just sharing my other screen here. This is a very small demo. This is a OAuth2 flow in action in real life. And this is also, for the most part, open source. I haven't uploaded the latest version yet, but if you're interested in that, I can also provide the link to it. The basic idea with OAuth2 is we redirect. So in the first step, we redirect the user to the login page of the identity provider that we want to use. And OpenID Connect specifies that this always has to be a domain followed by /authorize. So this is something that OpenID Connect specifies. So we only have to replace the domain. But whenever we hit this endpoint with these query parameters, we will end up in a login page with which we can authenticate with any identity provider. And once we did that, then the identity provider authenticates the user. They do all their magic. And here we have a callback URL. That callback URL says, once you're done, redirect or send an auth code to this specific endpoint, and also redirect the user's browser to the specific endpoint with the auth code within it. And what we do then is, once they hit our callback URL, we also have a standard process to say, now we have to send it to the token endpoint. This is something that OAuth2 specifies, to get an access and an ID token back and to lock the user in. So basically now this is the step where we convert the auth code for a token. And then in your request, in the response, we will get that access token back and eventually an ID token if we specify so. And just to show you how easy it is once you got the initial layout done, here we have an Auth0 integration. So these are just all the settings for Auth0. And if we start the server now and log in, go out of here for a minute to localhost 8080 login, press in an incognito tab, so you can actually see the login happening. We're now redirected to Auth0. So now here on Auth0, if I sign in with my private email.
Tobias, we can see only the Google Docs view. So we don't see your private tab.
Then let me just share all of my screen. Can you see the Auth0 login now?
Yes, thank you.
Awesome, thank you. So let's do that magic again. When we go to our login server, so here it's just localhost 8080/login, we will be redirected to Auth0 because of the information we gave the tool. And if we now sign in, you see that we get an access token and an ID token back. And more on that in a second. But if we now change our configuration in here and we say, don't use this configuration, but use that, which specifies a GitHub login, but the code stays exactly the same. And we again go to login. We're still logged in because it's still cached and because it didn't restart the server. When we now go to the login box, you see now we are able to sign into GitHub with our username and password. We could follow through that. And in the end, we would again get an access and an ID token through GitHub now. That is the power of standards. It makes it really easy to adapt your tools. And so the final things I want to show you in there is now we established how we would access this, but now the question is, how do we transport all this information about access and ID token? And I want you to take away basically what those JWTs are, those Json Web Tokens. This is a standard form of transporting all of this information from A to B. So it's basically when you do this authentication flow, you get back this weird text here. And this weird text actually is following a very strict syntax. This is a base 64 encoded string, which consists of a header, which basically says, how was this token created? A payload, which is just a JSON object. What information does this token carry? any signature, which is a hash on the first two parts, using a private key that only your authorization server knows. And the authorization server gives you the public key on a public endpoint. This is what the OpenID Connect specifies. And through that, you can verify this token. Well, the cool thing is, even without verifying it, you have information in it. So it makes it easy for you, once you trust that token, to use the information within your app without having to do unnecessary requests from A to B. But also it gives you the, it ensures that you can verify that this token actually comes from an instance you trust, namely the authorization server you would expect, and that your service is secure. And if we just take a small look at that, once Google lets me change my slides again. If we look at the ID token, for example, which also counts as a dot, and we go to this little debugging tool called dot.io, we can copy and paste it. And the red part is the header, which specifies with which algorithm was the signature created, what type of token is this, and also what is the ID of the public key that can be used to verify this token. Then the purple part is just all the payload. So who is that user we're actually talking about? Where do they come from, etc. And then this is the signature. If we would copy and paste the public key in here, the correct one, this is just a demo one, we could actually verify this token here with our authorization server. So then we would send that, we could verify that, and we can make sure this is actually something our authorization server gave us. Last thing I want to show you, just because it's so cool. I know I'm already 1 minute over 30, but I just feel free to take 4 more minutes, is now that we established what is the current status quo. So those 3 things I just showed you, this is how essentially every modern identity provider works under the hood. Last part is what will come up in there. And I just want to raise awareness for this new standard called WebAuthn. What WebAuthn allows you is using YubiKeys or any device biometrics you have on your system to be used on any website out there. So it enables you to use Windows Hello, Apple Touch ID on your Amazon.com account, on your LinkedIn.com account, your GitHub.com account. And if you're interested in this, there are SDKs for doing this, and I recommend you use an SDK. I tried to implement it myself once. It was not fun because it's really, really complex, and there's a lot of cool security stuff under the hood. But for your users in the end, it just means they basically register on your website. This registration process will then register with your browser. You put that to your device, and your device will give you a hardware encrypted challenge, which can ensure that once a user authenticates here initially with their biometrics, for example, here for example, with their sensor data, with the Apple Touch ID, that you can then have a strong verification, which basically says your device now knows that you are registered in this website with your Touch ID whenever you want to access it again. So all the security lies on your device, not on the server of the service you want to access. So it's very secure for you. And as the basically credential that is actually you is encrypted by your device itself, you are, it's very unlikely to be hacked because all the encryption happens on a device level, on the level of the security module you have in your device. And what I can do then is, when I click on next, I can basically log in to the server. So whenever I want to log into any website now, it will do some magic stuff, and then I can use my fingerprint ID and I'm signed in. Easy as that. And it is something, while not going into the protocol, because each of those registration and login steps has, I think, 34 different things you have to do, like literally 34 steps to verify all credentials, etc., are secure. I just want to show it to you. If you want to build something, I think this is something that will help you a lot to build a great user experience. In essence, though, showing you all of this, and this is partly going back to my own experience, partly going back to the marketing stuff. Authentication can be really hard, and there are a lot of specs and moving pieces in it. If you just want to build a basic service that uses OAuth to integrate with Google and Facebook, this is something you should definitely look at, take a look into. And if you want to go deeper into that, I can promise you a very fulfilling career in cybersecurity. But if you're a developer who doesn't want to take care of all of that and who's don't want to deal with all those complexities, seriously think about using a managed security service that frees you up from all the development stuff I just showed you and gives you more time to focus on the user experience around all of those basic protocols that we just mentioned here. And that being said, this was a sprint through all the security stuff. If you want to, we can take 5 or 10 more minutes for questions if there are any. Other than that, thanks for sticking with me, and thanks for taking this ride through front-end security.